This video is about identifying parallel, perpendicular, and skew lines, identify the transversal, and identify angle pairs. So first let's talk about what parallel lines, perpendicular, and skew lines are. So parallel lines are lines that have the same slope and they do not intersect. So for example, we have parallel lines that would be going the same direction, they have the same slope, and as much as I extend them, they're still never going to intersect. Perpendicular lines are lines that are going to intersect at right angles, which remember makes 90 degrees. So if I have a line here, another line coming across with a little box in the middle, remember that box means that it's a right angle, so those lines would be perpendicular. Skew lines. Skew lines are not parallel and are not perpendicular. They're lines that run in opposite directions in a 3D figure. So think about if I had a cube. Here's my cube. Skew lines would be going in opposite directions. So we might have this back line which is going left to right, and then one of the sides in the front that's going up or down. They're never going to intersect, but they're also not parallel and they're not perpendicular. And then we have parallel planes. Parallel lanes are just sides of a three-dimensional figure that are never going to intersect. So let's try identifying some of them. So in number one, list two pairs of parallel lines. So over to the right, we have a triangular prism because it has two triangular bases. So we want to look for two pairs of parallel lines. So one pair of parallel lines could be JM, which is going on a diagonal, and EB. They're both going in the same direction, but they're never going to intersect. So JM and EB would be an example of parallel lines. Another example of parallel lines could be UL and JE. They're both going the same direction and they're never going to intersect. Perpendicular lines. So perpendicular lines are forming right angles. So one of the obvious ones has our little box over by U. So we would say that JU and UM are perpendicular. Because they're perpendicular at U, and that's where the right angle is formed, U is going to show up in the name of both lines. Another example that's a little less obvious is if you look at the front of my prism, I have this rectangle shape. If it's a rectangle face, that means it has to have right angles. So another thing that could be perpendicular could be JE and JM. Skew lines are two lines that go in opposite directions. So an example of skew lines could be UM and EL. They're on different parts of the shape and they're going in different directions. So they're never going to intersect, but they're also never going to be perpendicular. Another example we could look at would be EB and UL. Going in different directions and they'll never be able to touch or intersect because they're on different parts of our 3D figure. Number two, list two lines that are parallel. So now we have a square or a rectangular looking prism off to our right. So we want two lines that are parallel. So two lines that are going in the same direction. We could have AR and we could have VI. Both of them are going straight up and down. There's a lot of choices here, but that's just one of the few. Perpendicular. So perpendicular, they're intersecting at the side and making a right angle. Notice that to be a right angle, it's going to have a square face. So anything that intersects at one of these corners would be perpendicular. So we could say that FE is perpendicular to ET. Skew lines. So skew lines are different parts of our shape going in different directions. So we could have AR again going up and down, and we could have VO going front and back. Another thing we want to look at is angles formed using a transversal. So a transversal is a line that intersects two or more lines. So right here in the middle of this first picture, it would be our transversal because it's intersecting the two lines that are going from left to right. So our first type of angle pair then, using a transversal, is corresponding angles. So corresponding angles lay on the same side of the transversal and on the same side of each line. Another way to think about corresponding angles is that in the group of four angles, they're going to be in the same position as each other. So an example of a corresponding angle would be 1 and 5, because they're both in the top left of their group. Another example would be 2, 6. They're both in the top right. 3 and 7, which are in the bottom left. And 4, 8, which are in the bottom right. Another type using a transversal are alternate interior angles. So alternate interior angles are non-adjacent angles that lie on the same side of the or on opposite sides of the transversal, opposite sides. And they're inside the line. So inside here, between these two lines would be our interior. If they're alternate, that means they're on opposite sides of our transversal, that highlighted line. So examples would be 3 and 6 and 4 and 5. Another type of angle then is the alternate exterior. So alternate exterior lay on the opposite side of the transversal again. This time though, they are outside the line. So our outside is above and below in this case. And we have our transversal intersecting both of those lines. So examples of an exterior angle would be angle 1 and angle 8, or angle 2 and angle 7. Another type of angle is same side interior using our transversal. So with same side interior, that means they're going to lie on the same side of the transversal inside the lines. So they're inside between these lines, and they're on the same side of that transversal that's highlighted in yellow. So an example would be 3 and 5 or 4 and 6. Same side exterior is the same idea, but now they're outside of our lines. So they're on the same side of the transversal, and they are outside the lines. So again, our transversal is intersecting both of those lines. So an example of same side exterior would be angle 1 and angle 7, or angle 2 and angle 8. Remember from Unit 1, we also have two other types of angle pairs that do not need transversals. We have vertical angles. Vertical angles are formed by our intersecting lines, and they are non-adjacent angles. So if I label my angles 1, 2, 3, and 4, 1 and 3 would be vertical angles, and 2 and 4 would be vertical angles. Linear pairs are angles that form straight lines. So if I have two intersecting lines again, they're going to form a straight line. So we would say that angle 1 and angle 2 are linear pairs, and angle 3 and angle 4. Remember, in a linear pair, they're going to form a straight line always. So let's identify types of angles looking and using a figure. So the first question says identify the line that's the transversal. So the line that's intersecting two or more lines in this case is this vertical line that's a little on a diagonal, line M. So we would say that our transversal is line M. Now we want to identify corresponding angles. So corresponding angles, remember, are angles that are in the same place of our line. So let's say, for example, we pick 4. If we pick angle 4, the corresponding angle has to be in the same position of the other 4 in the other 4 group, which would be angle 8. So an example of corresponding angles in this picture would be 4 and 8. Number 5, alternate interior angles. So remember, alternate interior angles need to be between the lines and on opposite sides of the transversal. So if I pick angle 3, my alternate interior, the other side of the line, inside would be angle 5. Alternate exterior, so same idea, but now on the outside of the line. and on the opposite sides of the transversal. So let's say we pick angle 1, the opposite side would be angle 7. So we could have angle 1 and angle 7 would be alternate exterior. Same side interior. So same side interior is between the lines, but on the same side of the transversal. So if we picked angle 4, angle 5 would also be on the same side. Same side exterior, so same idea again, but on the outside of our lines. So if we picked angle 2, the angle that's on the same side of angle 2 is angle 7. They're just on the outside of our lines. Now let's look at, given an angle, we need to determine if it is, what type of angle pair it is, and state the transversal if there is one for the pair of angles. So in number 10, we have angle, or number 9, we have angle 10, and we have angle 14. So determine the transversal, we want to look at what line are both angles touching? Well, both angles are touching D. So D would be our transversal. And now I want to look at those angles. So if I look at those angles, I'm really looking at angle line B and line C. Well, those angles are between the lines, so they have to be interior, and they're the opposite sides of the transversal. So these angles are alternate interior angles. Number 10, looking at angle 1 and angle 4. So the line that angle 1 and angle 4 share in common is line A. So line A is our transversal. Now when I look at angle 4 and angle 1, they're above and below their lines, which means they're on the outside and they're on the same side of the transversal. So these are same side exterior angles. Number 11, angle 4 and angle 6. We have to be careful with this one. Angle 4 and angle 6 are in the same pair of angles of the group of 4. So the only thing that they could be are vertical or linear pair. So they do not have a transversal. And when I look at them, they're on a diagonal from each other, which means that they have to be vertical angles. Number 12, 7 and 13. 7 and 13 do not share a common line, and they're not in the same group, which means that they have no transversal. They also have no relationship then. If they're not in the same group or share a common line, they can't have a relationship with each other. Our next pair is angle 14 and angle 4. So angle 14 and angle 4. They are both sharing this line C because they both are touching line C. So we would say that C is our transversal. And then looking at the angles, they're on opposite sides and they're outside of the lines because there's outside here and outside here. So these would have to be alternate exterior angles. Number 14, we have angle 2 and angle 3. So when we look at angle 2 and angle 3, they're both touching the same line A, which makes A our transversal because it's going through the two lines that they are also touching. So A is my transversal. And when I look at these, they're between the other two lines. So that means they have to be interior and they're on the same side. So this is going to be same side interior angles. Number 15, angle 8 and angle 1. So angle 8 and angle 1 are in the same pair again, which means they can only be a linear pair or vertical. But because they're next to each other, this means that they form a straight line, so they have to be a linear pair. So they have none for a transversal, and they are a linear pair. Number 16, when I look at angle 7 and angle 15, they're both touching line B, so line B is going to be our transversal. Now, this one gets a little bit tricky because one is inside and one is outside. But if I really look at the group of four, I can notice that the angles are in the same position in the group of four, which means these have to be corresponding angles.